Hey guys, today we are going to graph rational functions and dive in a little deeper. My disclaimer is going to be that this can get overwhelming. Just practice, follow the examples, watch this video as many times as you need to. You can Google any other video. There are a ton of videos out there to help you. I tried to keep my steps consistent with the steps I saw when I Googled because I know some of you are going to do that. So step one, you are going to find the x-intercept. Remember, if I am trying to find where my function hits the x-axis, all of these points along here always have a y value of 0. So when you're finding the x-intercept, you're really just subbing in 0 for y. Similarly, with the y-intercept, if I go all along my y-intercept, all of these points have an x value of 0. So when you find your y-intercept, you're just plugging in 0 for x. So that should not be that overwhelming. Remember, big warning that we need to focus on there are two golden rules in math. We cannot divide by 0, ever. So we need to pay big attention to our denominator. Our denominator cannot be 0. So when we look at our denominator, because that fraction bar in your rational expression is just a division sign. When you look at your denominator, figure out what your restrictions are so you know which values x cannot equal. That's the number sign, not hashtag. And then if there is a common factor, like if we have, when we factor, say we have an x minus 3 in the top and an x minus 3 in the bottom, this is a common factor. So common factors lead to a unique situation called a point of discontinuity, commonly just called a hole. So since it is a point, we are going to write it as an x and a y, and we're going to use the x value that it can't equal, and then solve algebraically for our y. If there is no common factor, but there's still something else down there, say there's like an x plus 2, then that value, which would mean it's negative 2, because that's the one that would make it equal to 0, would be a vertical asymptote. We are going to do examples of this, so just bear with me. Step 3 is a big one, but it's not really. So when it is in standard form, so if you're looking at the degree, you want to look at, most of the time it's just the original. So not factored form, you want to look at standard form, because we are actually, I'm not sure why it's erasing, sorry about that, guys. We are actually going to be looking at the exponent. So the exponent is the largest degree. So then you're going to remember this very silly phase. Bobo Botan eats DC. My stylus is going crazy. I'm not sure why. Okay, so Bobo stands for bigger on bottom equals 0. So if the bigger exponent is on the bottom, we are going to have a horizontal asymptote that is equal to 0. If bigger is on the top, then we have none. So bigger on top, none. So you do not have a horizontal asymptote. Each DC stand for exponents are the same. We're going to divide our coefficients. So by coefficients, they actually mean your leading coefficient. So you're going to take y equals your leading coefficient divided by your leading coefficient. I am distracted because it keeps setting it on erase. So hopefully this will stop. Okay. So I would suggest you factor and you look for holes first. Most online resources did not do that, but if this was my expression, I would think of this as what multiplies to be 8 adds to be negative 6 would be negative 2, negative 6. In the denominator, what multiplies to be negative 2 adds to be negative 1 would be positive 1 and negative 2. So I want to, right off the bat, I know that my denominator values cannot be equal to 0 because you can't divide by 0. So you might want to make a note somewhere, x cannot equal negative 1 and x cannot equal 2, because what plus 1 would be 0, negative 1, what minus 2 would be 0, positive 2. So since this is that common factor, that means that at x equals 2, I'm actually going to have a hole. So I'm not going to have a y-intercept there. I'm not going to have anything there. I'm just going to have a hole, and we'll come back to that. All right, so x-intercept. We talked about x-intercept means that y is 0. if I were to solve this and put y equals 0. So 0 equals that big mess. We would put this over 1 and cross multiply. So 0 times your denominator is always going to cross out. So a shortcut for finding your x-intercept for rational functions, this is only for rational functions, but for rational functions to find your x-intercept, you're really just setting your numerator equal to 0. Again, I'm very sorry it keeps erasing it, but set your numerator equal to 0. Quickly write that down before it erases. Okay, so 0. Come on, pen. Please work with me. So sorry, guys. 0 equals x squared minus 6x plus 8. So we would have our factors that we already talked about, right? So we know that x minus 4 equals 0 is going to be an intercept. So at 4, 0, that's an x-intercept. This one I can ignore because that was a common factor. So that common factor trumps everything else because remember, golden rule, you can't divide by 0. So if it shows up in your denominator, it's a really, really crucial point. So x equals 2 is going to be a whole that we're going to work out later. All right, similarly, y-intercept means that x is 0. So if I go over here and I want to solve for y, when x is 0, I'm going to have y equals 0 squared minus 6 times 0 plus 8. So that just gives me y equals 8 in my numerator divided by 0 squared minus 0 minus 2, negative 2. So what's going to happen with your rational functions for your y-intercept is it's really just going to be the constant values. Those constants mean they're not attached to variables, the constant values. So 8 over negative 2 is negative 4. So my y-intercept is going to be at 0, negative 4. Okay, so now we are focused on these denominators. We're on step 2 in your notes. So I'm going to look. Any common factor gives me a whole, which is a point of discontinuity. So let's look at that now algebraically. So we know from our first lesson, simplifying rational expressions, that if we have common factors, I can divide x minus 2 divided by x minus 2, and that becomes 1. So that would leave me with x minus 6 over x plus 1. So x minus 6 over x plus 1 is going to be this whole, and I know that my x is 2. So if x is 2, this is really just saying 2 minus 6 over 2 plus 1. So 2 minus 6 is negative 4. 2 plus 1 is 3. So at 2, negative 4 thirds, I'm going to put a whole. So on my graph, I'm going to go 2, negative 4 thirds, which is a little bit more than negative 1, and I'm just going to put a whole in my graph. Vertical asymptote is anything left that is undefined. So this one we already addressed, it was a whole, which means this one is going to be a vertical asymptote. So I'm going to set up my electric fence or my vertical asymptote at x equals negative 1. Can't touch that value. Horizontal asymptote. So think Bobo Batten eats DC, and we are looking at the degree of the original. So if I look at my degrees in my original, my degree in my numerator is actually 2. My degree in my denominator is 2. So the numerator equals the denominator. Exponents are the same. Divide coefficients. That's what eats DC stands for. So if I divide my coefficients, since they do not have a number in front, I know there's really a 1. So 1 divided by 1 is going to give me a horizontal asymptote at y equals 1. So I'm going to set up my fence. I do not want to touch y equals 1. Domain and range we'll come back to after we sketch this graph. So here's where you really might want to use Desmos, and that's totally fine, especially if you don't have a graphing calculator. But when you look at Desmos, and I try to put it in for you, you will see that your function is going bottom right, top left. So I am just going to sketch my line and not worry about being perfect. Bottom left, top right. And I want to make sure I don't go through the whole. I don't want to hit any asymptotes. You will see if you look at the table, so you can hit the little settings and look at the table. Negative 1 is undefined. We know that because that's an asymptote. 2 is undefined because that's our whole value. Okay, please try number 2 before I go over it. So pause it, try it, then come back to this. All right, x-intercept. y equals 0. So shortcut is set your numerator equal to 0. So I have y equals 0 is a possible x-intercept. Y-intercept means your x is 0. So 0 minus 1 is negative 1. 0 squared plus 2 times 0 minus 3 is negative 3, which means 1 divided by negative 1 divided by negative 3. Ay, 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 this pen. Gives you 1/3. So my y-intercept here is going to be 1/3 0. Nope, nope, nope. 0 1/3. Okay, we did have a 1 there. Vertical asymptote means you absolutely have to factor. So nothing to factor in the top. Multiply to be negative 3, add to be negative 2, positive 2 would be plus 3, negative 1. All right, so x cannot equal negative 3. X cannot equal 1. These values would make it undefined because I would divide by 0. So x equals negative 3 is not common, so I have a vertical asymptote at x equals negative 3. Go to negative 3. There's my electric fence or my asymptote. There is a whole here because this is a common factor. So x equals 1 is actually a whole, so I can ignore that there. There's going to be a whole. Where will it be a whole? So if I think about lesson 1, x minus 1 over x minus 1 is just going to be 1. So I'm really looking at algebraically 1 over x plus 3, and I know that my x value is 1. So if I sub that in, 1 plus 3 gives me 4. So this will be 1 over 4, or 1/4. So at 1 1/4, I'm just going to put a whole. Again, it's not going to be perfect, especially using a stylus that's not being very nice. Okay, Bobobot needs to see. When I think about my horizontal asymptote, I want to look at the original. So if I'm looking at the degrees of this original, the degree of the numerator is 1. Degree of the denominator is 2. So the numerator is less than the denominator. Bigger on bottom. So this is a bobo. Bobo means y equals 0. So this is going to go right here. Okay, I might want to check Desmos or my graphing calculator. I'm going to come down here and show you what it would look like. So you see that it goes through here, top right, and then it's bottom left. And I want to just approach those asymptotes. I forgot to talk about domain and range in that first one. So we're not going to rewind back to that because this video is probably going to be long enough. So domain is your x, so make sure we go negative infinity. We want to skip over that negative 3. This one's kind of wonky because now we go negative 3 to my whole. Remember, x can't equal 1 either, so I need to skip over that. And then I'm going to go 1 to infinity. Your range is your y, so we just need to look at the y-axis. The only thing y can't be is that 0 value. So my range is negative infinity to 0, union 0 to infinity. Okay, example 3. Try it before I do it, please. All right, let's get into it. So x-intercept, set the numerator equal to 0. So I'm going to think that my x-intercept is 3, 0. What minus 3 equals 0? 3. Y-intercept, go ahead and sub 0 in for your x values. So this would give me y equals negative 3 over negative 9, 1/3. So 0, 1/3. Vertical asymptote, I want to factor. So can't factor the top. The bottom is a difference of squares, so x plus 3, x minus 3. So I know my restrictions now. What plus 3 is 0, negative 3. What minus 3 is 0, positive 3. So these denominator values, factors, give me my restrictions. So x cannot equal 3, which means I do not have an x-intercept at 3. I do have a vertical asymptote at negative 3 because that comes from this one. This is not common, and what plus 3 is 0 is negative 3. A whole comes from this common factor. So at positive 3, since what minus 3 is 0 gives me positive 3, I'm going to have a hole at what's left after I cross out or eliminate as 1 that common factor. So 1 over x plus 3 would give me 1 over, my value is 3, 3 plus 3, 1/6. So I'm going to have a hole at 3 1/6. I'm going to have a vertical asymptote at -3. Now I'm on to my horizontal asymptote. Bobo Botten eats DC. This is bigger on bottom again. So I'm going to have a horizontal asymptote at y equals 0. There I go. And now I'm just going to sketch my graph. So again, if you need to look at your calculator, you'll see top right, bottom left. This should really be approaching that line a little bit more. And now let's talk about our domain. Oops, I lost that now. Good thing you can see it down there. All right, so your domain, come on, is going to be all real numbers except those restrictions. So I'm going to say negative infinity to -3, union -3 to 3, union 3 to infinity. I just can't have x equal to this. Y can be everything except for the horizontal asymptote, so your range is going to be negative infinity to 0, and then 0 to infinity. All right, example 4. Try it before I do it, please. All right, here we go. X-intercept, set your numerator equal to 0. So x squared minus x minus 6. So we're going to have -3 and +2. So I'm thinking that this pen is really making me mad and I don't know what I'm doing. I'm very, very sorry. So if I have my factors at x minus 3, come on, please. This is the last example. X minus 3 and x plus 2. That means 3, 0, and -2, 0 are potential x-intercepts. Y-intercepts, we are going to sub in 0 for x. So my y-intercept is going to be -6 over -3, which is 2. So 0, 2 for that one. That's a 0, 2. Vertical asymptote, now I'm going to factor this. So I've already factored the numerator, x minus 3, x plus 2. Remember, it's only the denominator that really restricts our values. So x minus 3 cannot equal 0, which means x cannot equal 3. So x cannot equal 3 is a common factor, and there's nothing else down there. So I do not have any vertical asymptotes for this one. I only have a hole, and that hole happens at 3. So to find the other half of the hole, make sure you simplify. This would give me 1 here. So 1 times x plus 2 over 1, or we know our x is 3. So what is 3 plus 2 divided by 1? Well, that's 5. So at 3, 1, 2, 3, 4, 5, I am going to have a hole. My horizontal asymptote, I'm thinking Bobo Botten eats DC. So if I look, I have a degree of 1 and a degree of 2. 2 is on the top, so the numerator is greater than the denominator, bigger on top, none. So I have no horizontal asymptotes. If I look at my graph, it's very, very tricky here because it looks like a straight line. But if you carefully zoom in, if your calculator had enough pixels to show you this, you would see that at 3, it's undefined, or you can simply just look at your table. So it looks like the linear function, which no surprise, it looks like y equals x plus 2. So start at 2, up 1 over 1. It looks like this graph, but it kind of hops over that x value. So when I write my domain is negative infinity all the way to 3, skip 3, and go to positive infinity. My range is going to be negative infinity to 5, skip 5, and go to positive infinity. Okay, here are 2 I want you to try. So I want you guys to try these, do your best, then come back and go ahead and check your answers on this slide. Okay, so if you need to pause this, rewind this, email me questions, come to office hours. Guys, I want to hear from you. I want to help you. I miss seeing your faces. Have a great day.